Good afternoon. My name is Blanca Martínez. It's a pleasure for me to be able to present with part of my work that is currently being carried out at CECyT Zacatecas, which is part of the Instituto Politécnico Nacional. This work was released in collaboration with CDTEC and UPIS. The title is One-Pot Synthesis of Hybrid Nanomaterials Based on Zinc Oxide with Silver, Cobalt, Tin, Graphene, or Manganese towards photocatalytic applications. The work is related to the one-step synthesis of different zinc oxide-based hybrid nanomaterials. It consists of a brief introduction, an experimental section, the results and conclusions. The main interest of synthesizing these hybrid nanomaterials is to increase the photocatalytic activity of the zinc oxide semiconductor using a simple and environmentally friendly synthesis method. In this work, the synthesis of these different hybrid nanomaterials was realized. Regarding the experimental part, this work is divided into three main stages. The first, which consists in the synthesis of the hybrid nanomaterial using the colloidal method. Then, presented the characterization by different techniques. And then finally, the evaluation of the photocatalytic activity by comparing it with commercial materials and with the same individual semiconductor zinc oxide using different model molecules such as diet and organic compounds. In this part of results, in figure 1, shows the absorption spectra corresponding to each material. In all cases, the characteristic absorption edge of zinc oxide can be observed. Considering this, the wavelength in which the material absorbs, it is possible to calculate the nanoparticle size using the effective mass approximation, as well as the value of the Blanca. The sum of these values shows on the table 1 for different nanomaterials and the same values of the Blanca. The summary of this data can be here. The size varies from 4 nanometers to 11 nanometers depending on different materials. After obtaining the boundaries of each material, they were characterization by using X-ray diffraction. Figure 2 and 3, the diffraction, when showed the diffraction patterns of each material, and in each case, this pattern corresponding to the good size structure type crystal, with the exception of the zinc oxide with cobalt, where several structures corresponding to the formation at different stages were detected for cobalt. In figure 5, 6, and 7 show the arching micrographs of the materials with cobalt, manganese, and silver. In this micrography, corroborate the crystal structure and nanoparticle size. Finally, in this table, the obtained results of the photocatalytic evaluation of the synthesized hybrid materials are shown. 3 different molecules were used. In this case, Bismarck brown dye was used. the maximum removal rate present with zinc oxide with silver in 1 hour. For the evaluation of degradation of a synthetic organic compound such anthracene, the hybrid nanomaterial zinc oxide with manganese was used. This nanomaterial achieved a 90.5% degradation in 40 minutes. In this case, when used these materials, the molecule model was used diamond blue and these values of the removal rate. In the same time, one of the conclusion of this work is zinc oxide with different metals such as silver, cobalt, tin, graphene, or manganese nanohybrid materials were successfully prepared by the one-pot alkaline hydrolysis synthesis. Same, the photocatalytic activity of zinc oxide increases substantially by incorporation the metals, in special silver, manganese, and tin, with the same graphene. Not in the case of zinc oxide cobalt, due to the formation of the other compounds. The presence of metals, ions, and oxygen mechanisms of the surface of the zinc oxide nanoparticles promotes the separation of photogenerated electron hole pairs and thus enhances the photocatalytic activity. The reference of this based in this work can be here. And finally, it only remains for me to thank the Instituto Politécnico Nacional for the financial support and the CECyT 18 students, Sania and Kyle. Thank you very much. Ok, entonces, presento el trabajo sintetizado, síntesis en un solo paso de materiales híbridos a base de óxido de zinc con plata, cobalto, estaño, grafeno y manganeso para aplicaciones fotocatalíticas. Una breve introducción. Nos interesa aplicar esta